So, welcome to the start of this workshop. As you can see from your itinerary, I am here to provide you with a background on the microbiology of chlorinated solvent fuel oxygenate biodegradation. My name's Mike Hyman. I come from the Department of Microbiology, North Carolina State, and I had experience dealing both with the organisms responsible for chlorinated solvent biodegradation and fuel oxygenates. Um, should recognize that this presentation here condenses a lot of introductory material. Hopefully some of it is a recap. If you do have any questions, please feel free to contact me after the event or during the question time. If you need to contact me afterwards, there is my email address. Be happy to reply to any questions you might have. So the way we're going to organize this is we are going to deal initially with Microbiology 101, where we're going to talk about the microbial diversity, some of the structures and functions, and in particular what we're going to look at are the features, the biomarkers, the biological molecules that are present in microorganisms that we can use to specifically answer questions such as which microorganisms are present in a particular environment, what potential does a particular environment have for biodegrading a particular compound, and how can we actually verify that organisms that we suspect are doing this are actually doing this. Again, as we're also dealing with the pathways and the mechanisms of biodegradation, we're also going to have to deal with these issues of microbial physiology, such as aerobic and anaerobic biodegradation, metabolism and co-metabolism, things that we've summarized up here. Obviously, some of the things that we're particularly interested in this workshop are some of the modern tools, and there's a particular emphasis on the use of stable isotopes. You're going to hear a lot about stable isotopes, looking at particular compounds and seeing how their isotopic composition changes. We're also going to talk about, to a lesser degree, but perhaps just as importantly from my perspective as a microbiologist, how stable isotopes can be used in conjunction with or to amplify what are called the molecular techniques, these molecular biology techniques. And these molecular biology techniques really interrogate these biomarkers, the structure and function of these organisms. For the sake of time and just for this demonstration, I'm going to just nip on to the next slide. This is what, so this is leading us into the microbiology section. So let's just first deal with this idea that this is, in fact, a microbial world. Microorganisms, there's evidence that microorganisms have been on this planet for nearly 4 billion years, which is 90% of the period the planet is believed to exist. There is an enormous diversity out there. So this little cartoon here shows you, hopefully implies that it indicates to you that let's not forget that ultimately this is a microbial world. We are very transient visitors here. This figure over here on the right shows you what is called either the tree or bush of life, and you'll see that there are 3 color codes here. 2 of these are organisms which are single-celled organisms, which we would call prokaryotes. Prokaryotes means that they don't have a nucleus, and that includes the eubacteria, which we otherwise know as the bacteria or the true bacteria, and then a specialized group of organisms over here called the archaea. Collectively together, those are called the prokaryotes. There are everything else that we see on this planet, and perhaps the things that we see most frequently, the plants, the animals, fungi, protozoa, etc., are what are called eukaryotes. Eukaryotes have a nucleus, and other features as well, obviously. If we sort of slip into the colloquial side of things, bacteria, archaea, and fungi are what we typically refer to as microorganisms, and so the term is kind of synonymous. Just to give you an idea of the total number of species that are out there and the uncertainty that exists with it, there's somewhere between 1 million and 1 billion microbial species are suspected on this planet. Um, and that really highlights one of the problems we have. How do we, in very complex environments dealing with very, very small organisms, identify which organism is doing which process which is of benefit to us?